Hey, what's going on, guys? Let's do this problem right here. This question is asking to integrate this one using trigonometric substitution. Now let's see how we can do this. So first of all, before we do this one, we have to know three conditions. Like whenever we have x square and a number square, we have to choose our x as x is equal to a tan theta, right? So this is going to be whatever the number we are getting right here, that times tan theta. Now if we have x square minus a square, in this case we have to use x is equal to a sec theta, right? And when we have a square minus x square, we have to use x is equal to a sine theta. So these are the three things we have to know before we do the trigonometric substitution. Now here we have x square plus 4, and if you notice, this is same as x square plus 2 square. So this is x square plus number square, right? So that one is same as the first condition, x square plus a square. So here we can use x is equal to a tan theta. Now let's write this one. X is equal to a tan theta. A is the number, right? So this number, that is 2 tan theta, and that's going to be the x value. Now we can replace x with this one, but we have to find something for dx. To find something for dx, because if we write theta, we have to write everything in terms of theta. So here, to replace dx with theta value, we have to take the derivative of this one. And if you take the derivative, we know that tan theta is equal to sec square theta. So this is going to be 2 sec square theta. If you take the derivative, this is going to be 2 sec square theta d theta, right? Now we can go ahead and write everything in terms of theta values. Now let's go ahead and write it. So this is going to be integration of 1 over, instead of x square, I'm going to square this one. So if I square this one, this is going to give us 4 tan square theta. So this is going to be 4 tan square theta, and in the square root we are going to have again 4 tan square theta and plus 4. And instead of this dx, we have to replace this value, that is 2 sec square theta d theta. So this is going to be 2 sec square theta d theta. Now let's see what we can do. So whenever you have this square root, we try to get rid of that one. So let's see how we can do this. So first let's bring this one on top. So this one is going to be 2 sec square theta d theta, and in the denominator we have 4 tan square theta, and here what we can do is we can take the 4 common. If I take 4 common, this is going to be equal to tan square theta plus 1, right? And you may notice this one can be cancelled, 4 and 2, and if you cancel this one, we are going to have 2 right here. And this 4 can be, like, we can take this one outside. If we take this one outside, that's going to be 2, and 2 times 2, that's going to be 4, right? So we are going to have sec square theta d theta over 4 tan square theta, and then we are going to have tan square theta plus 1 in the bracket, in the square root. So this is going to be tan square theta plus 1. And how can we get rid of this one? If you remember this one, tan square theta plus 1 is equivalent to sec square theta, right? So we can replace this one with sec square theta, because we can get rid of this square root, right? So let's see how we can do this. So here we are going to have integral sec square theta d theta over 4 tan square theta, and then if I replace this one with sec square theta, we can get this one out of this square root, and this is going to be equal to integral sec square theta d theta over 4 tan square theta sec theta, and here we can cancel these sec values. So this is going to be this square and this one cancels. So we are going to have sec theta over 4 tan square theta. Now to simplify this one, what we can do is we can write this one in terms of simple terms. But before I do that, I write this one again. This is going to be sec theta d theta over 4 tan square theta. Now sec is reciprocal of cos theta, so we can write this one as 1 over cos theta, and we have this 4 right here. I can take this one in front side, and we have 1 over cos theta, and also we have 1 over tan square theta, because if I separate this one, let's say this is going to be 1 over 4 integral sec theta over 1 and then 1 over tan square theta d theta, right? So instead of tan square theta, we can write sine square theta over cos square theta, and if I write sine square theta over cos square theta in the bottom, that cos square theta can be brought to the top because it's going to flip around anyway, right? So we can write this one as cos square theta over sine square theta d theta, and here we can cancel this cos theta and cos square theta, so we are going to have so this is sine square theta, right? So cos theta over sine square theta. Now we are going to have this one 1 over 4 integral cos theta over sine square theta d theta. Now what we can do for this one, and whenever you see the derivative on top, we can do the Joule substitution, right? So here we can do the Joule substitution. If I take Joule as sine theta, the derivative of this one is going to be cos theta d theta, right? So cos theta d theta. So I can write everything in terms of u. Now let's go ahead and do that. Maybe I get rid of these parts right here. So let's continue this one right here. Now I write u is equal to sine theta. So let's continue this one right here. So if I write everything in terms of u, first we have 1 over 4, that's going to remain the same, and in the top we have cos theta d theta. Cos theta d theta we can replace with du. So this is going to be du, and then we have 1 over sine square theta remaining. We know that sine theta is equal to ju, so 1 over sine square theta is going to be 1 over u square, and this can be also written as 1 over 4 integral u power minus 2 du, right? If you do the integration for this one, this is going to be 1 over 4. If we do the integration, we have to add 1 more to the power and divide by the power. So here we are going to have u power minus 1 over minus 1 plus constant, right? Now this is our integration. So now let's write this one in a better way. You know what, maybe I take these parts outside because we don't have enough space. Let's get rid of them. So here we are going to have this one 1 over 4 u power minus 1 over minus 1 plus constant. Now let's write this one in better way, like minus 1 I can take to the front, so this one will be minus 1 over u power minus 1 is same as 1 over u, so this is going to be 1 over 4u plus constant. Now our original form is, this question is not in u form, this is in x form, so we have to bring this back to x form. Now before we do that, we have to do we have to bring the theta pattern first. So this is going to be minus 1 over 4, instead of u we have to replace with sine theta. So this is going to be 1 over 4 sine theta plus constant, and our original wasn't in theta format, so we had to write this one in x format. Now to bring this one into x format, we have to use this one. This is the one we previously took. X is equal to 2 tan theta, and we replaced all the x with these values. Now we have to find out what's going to be the sine theta. To find that one out, we have to take this again. We know that x is equal to 2 tan theta. Therefore, tan theta is going to be equal to x divided by 2. So in this case, we have to create a right angle triangle. And if we take theta as this one, and we know that tan theta is opposite of adjacent. So here the opposite is going to be x and adjacent is going to be 2. And using Pythagorean theorem, if we take this one as a, we know that a is going to be equivalent to x square plus a square is going to be equivalent to x square plus 2 square. Therefore, a is going to be equivalent to square root of x square plus 4. So we can replace this one with square root of x square plus 4. And we know that sine theta is opposite over hypotenuse. So here we can replace this sine theta with 1 over 4 is going to remain the same. Sine theta is going to be opposite over hypotenuse. So here the opposite is x. And the hypotenuse is square root of x square plus 4. So if I write this one in bottom, it is same as flipping around, write it on top. So we can, instead of writing on bottom, we can write it here. So this is going to be x square plus 4 and plus constant, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.